Hello everyone, today we are going to learn one important technique for simplifying and speeding up the modeling process in COMSOL multiphysics. We will learn how to organize and group certain geometrical features such as faces, edges, boundaries, and whole geometrical objects in selections. In this way, we can significantly speed up the modeling process. The main advantage of this disciplined modeling approach is that we can easily assign boundary conditions or loads or even heat fluxes to certain geometrical regions. For example, you can see over here a 3D geometry of an object. And for example, if you've modeled this in COMSOL multiphysics, your next task would be to assign, let's say, boundary conditions to certain regions, or to assign forces or heat fluxes to certain areas. Having this geometry, it's kind of difficult to approach, for example, the bottom of this part over here that you can see over here, right? And to assign, for example, a boundary condition, a fixed boundary condition to this surface in structural mechanics module, right? Or it might be difficult to approach one of the regions of this object in the final geometry that you can see over here. You can also imagine a more complex geometries of 3D objects, right? For example, a crankshaft or a kinematic mount or any type of mechanical system that's more complex than this one. Now, having the final geometry and assigning a boundary condition on such a geometry is a tedious task. Instead, while modeling, you can group certain regions and you can assign selections to these regions, or you can group these regions in selections, and then while assigning the boundary conditions or assigning, for example, loads or heat fluxes, you can just select from the menu the name of the boundary or the name of the selection, and you can automatically assign certain boundary condition to this selection without having to rotate this object, to hide this object, or to manipulate the geometry. So this is a disciplined approach of modeling, and I strongly advise you that you adopt this approach as early as possible because it will simplify your life in future. I'm telling this from my experience because I struggled a lot with assignment of boundary conditions on complex geometry, and I realized while modeling, group everything in selections. This is why I'm making this video. So this is the geometry, and in this video I'm going to recreate this geometry. So besides learning how to organize geometrical features in selections, I'm also going to give you a simple and brief crash course on how to model this geometry. Okay, so let us start. We click on File, New, Model Wizard 3D. We click on Solid Mechanics, Add, Study. It's not important, you can choose, for example, stationary or time dependent. I'm going to choose time dependent. In any case, you're not going to use any study in this video. Okay, so let us start. First, I'm going to build the inner structure. So I start with a cylinder. Radius is going to be 1 and height is going to be 0.3, and you click on Build Select. So this is our first cylinder. Okay. The second one, you can just duplicate this one and change the parameters 0.5, 0.6. Great. Now, you can make a difference between these two cylinders. You click on booleans and partitions and you click on difference, and you basically want to subtract these two objects, and you click on keep an input object and click OK. Great. So let's build the side cylinders. You can click again on geometry, cylinder, and enter the parameters. The parameters are going to be 0.1, 0.3, and position is going to be 0, 0.9, and 0.15. Okay, now you have to choose the axis. In this case, you're going to choose the y-axis. Okay, so here is our side object. The next step is to build the sphere. So how to do that? You can click on geometry, click on sphere, and enter the parameters. The radius of the sphere is going to be 0.1, and position is going to be 0, 1.2, and 0.15. Okay, so here is our object. The next step is to rotate this object. Unfortunately, COMSOL does not have an option to do a polar array, because in any CAD software, for example Fusion 360 on AutoCAD or SolidWorks, you can simply make an array 90 degrees difference between the objects, and you can make these 4 side objects. However, unfortunately, COMSOL does not have this option. However, we can rotate these objects. It is easy. We click on rotate, we select the objects, we select keep the input objects, and we select the angle. Angle is going to be 90, and we click on build select. And then we repeat this operation. Okay, we click on duplicate, and we are going to select here 180 degrees. Okay, now I made a mistake here, since I also have to select these two objects and build select. Okay, so here are our objects. Now let us create selections. This is the important steps. So we're going to create several selections. How to create selections? Well, in the definitions over here, you can do a right click, and here you have selections. And you have several options for creating selections. Explicit selections, if you click on these selections, you can basically create selections but manually selecting certain domains, or if you want boundaries, you can select boundaries. Even edges, right? If you want to have edges, you can select them. Here are the edges. Or you can even select points if you want. That's one option. Let's see what are the other options. Besides explicit selections, you can also have ball selections. Okay, so if you click on ball selection, you can specify a ball, and everything inside of this ball will be basically selected. You can select the domain. Let's select the boundary. Let's test this. So let's group the ball at 0.00 and put this radius of 0.5. Let's see what will happen. Okay, this will be your ball. Okay, you see that you can select that this selection finds this surface, and you can click to see what are the other objects being selected. So basically this operation finds the intersection between all the boundaries, or you can even click domains, right? Or edges, all edges that are part of this ball. Actually, to be more precise, at least some portion of these geometric entity should be inside of this ball, and this ball will be selected. You can further explore possibilities for selecting objects and different options. However, I'm not going to explain all the options in this video, since I don't want this video to be several hours long. Instead, I'm going to use explicit selections. And here, I'm going to deselect wireframe view such that we can select objects. And I'm going to select boundaries. So I'm going to select boundaries that are on the top, or let's put it like this, okay? Top boundaries, and I'm going to call top boundaries. This will be the name of my selections. And what is nice thing, you can always assign colors. Let us assign certain colors, and we click on build all. Okay, let us create other selections. Again, explicit, and let's call this selection side boundaries. Okay, we click on boundaries, and we're going to find the side boundaries. And here we're going to, let's say, use this color. Okay. Then another selection, bottom boundaries. Okay, so let us select bottom boundaries. As color will be green color, and let's create selections for side objects. We click on, or domain, side, we can call them side objects, doesn't matter. And these will be our selections. Okay, this is good. Now we have our selections, so let us recreate the lower part of geometry. So how to create a lower part of geometry? Easily. We are going to define a work plane, and then what we are going to do, we are going to basically revolve. We're going to sketch it in 2D, and we are going to revolve this work plane. So we're going to choose YZ work plane, ZY work plane. Here is our work plane, and here's our geometry, right? And now we have to just recreate the lower structure. In interest of time, I'm not going to show you how to enter the coordinates. However, this is our geometry in 2D. How I created this geometry? Well, what I did, I clicked on plane geometry, I clicked on polygon, right? And then I entered the points, right? And as the result, here's my geometry, and here are the points, right? You can copy and paste them, or you can directly enter them in your window. Then, the next step, of course, is to revolve this object. So we click on geometry, we click on build all, and we select the revolve option, right? You can see that automatically here COMSOL selects your face, right, that you want to revolve. And let's see what happens. There is an error. Why? Because you need to select the axis, right? You need to select the axis, revolution axis. So you need to select the point, right? Direction of revolution axis, right? What is the direction? Let's see. What will be the direction? You need to select the 3D option, and we are going to revolve around the z-axis. So this will be 0 and this will be 1. Let's see what happens. Perfect. Here is our geometry. Now the final step is to translate this geometry a little bit in the upward direction. So how to do that? Well, you click on geometry, you click on transform, and you click on move. Here you specify the displacement, let's say this displacement, you click on build select. You didn't provide the input geometry. Well, I'm going to click here and then I'm going to do this. Okay, so here's our final geometry, and we can create a new selection. If you click on here, explicit, we can select domain and we can click here, and let's call this lower part. Okay, perfect. These are our geometries, right? We can create another selection where we can group all these elements, other elements, except this lower part, in another object. However, we don't want to do that. Okay, so let us see what is the advantage of using this approach. Now, click on solid mechanics. And let's say that we want to assign a boundary condition to bottom boundaries, right? So we want to assign, you cannot see it over here, right? You cannot see a bottom boundary, but if you click over here, you can see the bottom boundary. It's the boundary over here that you cannot see behind the structure. Okay, so how to assign a boundary condition? Well, you simply click on solid mechanics and you click on fixed constraint. Now, selection here, you see, magic happens. So you can select geometries or geometrical features by just clicking here. You don't need to bother yourself to select from the geometry. You just click, you just click, okay, I want to have side boundaries. Perfect, perfect. You see how many selections? You will have to click thousands of times. I mean, on this geometry only a few times, but if you have a very complex geometry, you will have to click many times. Perfect. Okay, you want to assign materials, no problem. So let's just add an arbitrary material from the library. Let's just take aluminum alloy, right? We click on aluminum alloy. And okay, let's not choose all domains. Domain, what do we want to choose? Manual? Let's choose the lower part. Perfect. Here it is. Okay, and of course you can use this to assign loads, to assign heat fluxes and other boundary conditions or other quantities, forces, heat fluxes, any type of inputs, pressures, initial conditions, etc. Okay, I hope that you enjoyed this video. If you like this video, support our channel or subscribe. Thank you very much and have a nice day.